All right, so we want to focus on getting the last functionality done, which is the delete functionality. So now we've gotten the ability to edit, right? And again, the delete functionality follows the same principle of the edit functionality, where we would, of course, have the file being read. We search for a particular name, right? So to delete, let me see if I could just map out the steps of the delete. Right? We read file, right? Search for name to delete. Then what do? Once we select and confirm person to delete, right? What we do is that marks person to delete from struct on the struct, and then we will write the file without deleted selection, right? So essentially, as I said before, if it is that I have my file and I load all of my persons into the file, right? So I load all my people into the file, and we have Hannah, right? We have Michaela. We have Chelsea, right? We have Tina, we have Gray. And we know that we're loading this and the names and the other associated stuff up into the file. Now I want to be able to edit my read file so that in my struct array, right, this is my list, which is my struct array, I'm going to place an additional field called write, okay, or something like that, right? Right or valid or something like that. And once this value has a particular value, right, that person's information will be written to the array. Okay? So what we have to do is that this delete is more concerned really about modifying the read function and the write function and the structure of our struct, the blueprint of our struct, than it is about actually writing the delete function. So in order to prepare for this, okay, we're going to add a new single character to the struct, which is, and I'll name this right, valid, right? You can name it anything. If you name it valid, okay. I was going to name it write the file, and then shorten it WTF, but then I realized that mightn't be so good for, like, somebody might be like, what is this WTF variable, right? So like WTF is WTF. So let's just go with valid. Okay. So valid now is a single character that when we do the read file, everybody upon being read is valid. Okay. So that's just one more thing that we're going to place inside of it. So we're going to say list at position list underscore I, when we read in the file, dot valid is equal to T. So set the valid tag to true so that this information could be written back to the file. So once we have a tag name valid, once we have list at position I, once I read somebody's information in, I will set their character value valid to true or to T, right? And T means that, this is a valid file, so write it. And then later on, I'll modify this write file to only write valid entities to the file. Okay, and we will have to come and change up this a little bit, because we want to write it in such a way that we don't end up with any spaces or anything to the file. Okay, but let's see about creating the delete function. So the delete, right? Void del mem, right? So we have a function called void del underscore member for delete underscore member. We can call that in the menu. Okay, so we remove the to do for delete and we say del member, and we call in this function here. And now we have to define the function for del member. So we say void del underscore member, right? And just like the edit, del member could start off by calling the search function. Okay, so it tells me, right, I call the search function with a value of 1 passed to it, so that I get a value, right? So that I get a value, so that I get to select from the results an index location to return. Okay? So when I call the delete member function, let's just see if this runs or if I did anything that, right, that prevents me from running it. It runs. So call delete member, it actually sends me to the search function. And if I had Tina to search, I have my Tinas, and I could say, okay, which one of these results would you like to use? Let's go with Tina Thomas. Okay, and nothing else will happen because we don't have anything here. But we could go forward and say printf, are you sure that you want to remove %s from your file? This option cannot be undone. Okay? Are you sure you want to remove Tina from your file? This option. Oops, what did I do? I think I closed off the. Nice. Yeah, I think I closed my file. What's up with that? Right. Right. So are you sure that you want to remove Tina from your file? This option cannot be undone. And of course, in the same way, because I have the LOC here, right, I have to show list at position LOC dot first, comma, list at position LOC dot last. So are you sure that you want to remove this person from your file? This option cannot be undone. Let them choose yes or no. Okay, so I could say char confirm, right? I could say scanf and tell them Y or N. Okay? So for a yes or no. And say scanf, sign S, ampersand, confirm. Okay? And after scanf, we put our get char. And we say if confirm is equal to Y, right? Then we want to go ahead and say what? We want to change the status of valid for that particular person to something that is not T, right? We could say F or something, so right, because the false. So we'd say list at position LOC dot valid is equal to F. Okay? And the thing is that we only writing the people in list with valid that has a T. So if confirm is equal to Y, then right, if they confirm that they wish to delete the user, change the right flag to F so that they will not get written to the file. Okay, but we still need at this point to change the right file, to represent this. Remember, we don't write TOF to the file. This is something that is done only in the program, only when the struct exists. You all understand me? Anybody have any questions so far? So when we read the file, that's when the field valid gets set to true. Because everybody was read successfully from the file, so their valid status is true. But if I confirm that I want to delete this person, then I'll change their valid status to F, so that when I go into the write file function, I'm going to put code that will prevent me from writing this person to the file. Everybody understand where I'm coming from here? Everybody understand where I'm coming from here? Nobody's listening? Nobody?
Repeat, sir.
Right? This field valid that is in my struct only exists while the program is in operation. So the purpose of that field valid is to say, yes, I want to write this person's information back to the file, right? If it is that I want to delete this person's information, then the status or the value inside of valid will change, and my code will, that's strange. I get char. Yeah. So, and my code is going to not write that particular person. So just like in the example here, if it is that I have, right, valid being true, let's say valid being true here, valid being false here, and valid being true here, then what does this mean? It means that when I'm checking to write back to the file, this writes to the file, this writes to the file, this writes to the file, this does not write to the file, and this will write to the file. Do you understand what I'm saying?
Yes, sir.
Okay. And we have some considerations to take in there as well. right? But we inside of delete member. So this is delete member sorted right now. The only thing that is left to do is to write file. And as we start messing around with write file, right, I want to make a copy of this file because, okay, I want to make a copy of this file because, you know, invariably you'll do something that will mess up this file and you don't want to have to retype all of this information, etc. So let's see this work, and just up to this point. It'll write back the file, but I haven't modified write file function to actually skip over writing the file. So let's see if the delete, enter first name Tina, right? You see Tina Thomas, sorry, Tina Thomas. Are you sure you want to remove Tina Thomas from your file? This option cannot be undone. Yes or no, right? Even if I click on yes, right, nothing happened because I didn't put any information in my file that should take out Tina Thomas. But we have some considerations now for writing to the file. Okay, for writing to the file. When we are writing to the file, you have to make sure, let's say for instance, I have a list of names to write to the file here. I'm taking out this name here, so it means that I need to make sure that if this is my second to last person, right, I need to check to ensure that there is more to write after when I'm deleting somebody. Okay? The thing is that I do believe that we have a size. So this would have been 0, 1, 2, 3, 4. We know that we have 5 elements to write. So if it is that we have some scenarios, let's say we have 5 instances to write. We're going to write this one, this one, this one, this one, and not this one. Remember, when we're writing to the file, when you're writing to the file, you're writing from this first element here and then put in, so 0, 1, 2, 3, 4. You're writing what is inside here, right? You're writing what's inside there, and then you put in a \n. So you're writing 0, then you write 1, and you put a \n. Then you write 2, and then you put a \. But look at this instance. We're deleting what should be the last one. So what should happen for when you write position 3? When you write position 3, what do you have to do? Should you write a \n for when you're writing position 3, given that you're not writing position 4, the last position inside of there? That's a question.
No.
No, because if you write position 3 with a \n, what's going to happen when you're reading in the future? You're going to get an error when you read this line because position 4 is not writing. So that means that when you are doing this delete, you just have to make sure that the last element, if the last element is the one to be deleted, you don't write the \n on the second to last element. You understand where I'm coming from with this?
Yes, sir.
All right. Let's check for any other element. If I had this here, and this is the one that I wanted to delete, all right? So this is the one that I wanted to delete. I write position 0, right? I write position 0. So that was scenario 1. This is scenario 2. I'm writing position 0, right? I know how much elements I'm supposed to write. So as long as this value here is not up to the count of how much ever value is -1, I know that I'm supposed to write a \n inside of there. So there are some logical considerations that you have to take into place, right? So I'm not writing position 1, I'm writing position 2, \n, position 3, \n, and then position 4 without a \n because I'm not supposed to write the last one with a \n, and I already have code inside of write file that does that, right? I said if list underscore I at position -1 is unequal to x, then write the \n. Okay, but then I also now have to put in more considerations for when I am deleting the last element, right? So because of the fact that if the last element is the one to be deleted, if the last element is the one to be deleted, then I can simply, if the last element is the one that is to be deleted, I could simply not write that \n, sorry, for the second to last position. Okay, and so we can achieve this in a couple ways, but we have to think through it. Okay. So let's just go over this write file function. We have x, which is our counter that goes through every element inside of our struct array, right? We have the file pointer. We open the file to write it. We say for every position in the struct array, what do I want to do? Well, the first thing that maybe I should do now is check to see if it's valid to write the file. Yeah? So I could check and see if char valid is equal to true, right? Because once it's equal to true, which is, hold on, I'm looking for it in my read file function. If it's equal to, then it means that I need to write it to the file. But if it's equal to f, then it means I should not write it to the file. Okay? So I can go here and I can say if, and this is the most basic, but we need to make a change. If list at position x dot valid is equal to t, what do I need to do, right? If it's equal to t, then maybe this rule should be followed. Okay? And let's just do this as it is right now. Okay, let's just do this as it is right now and see how it works out for us. Whether this works out in some way or not. So let's take a look at the file. Right, this is our file, and we're going to delete Tina Ali. Okay, we're going to delete, it's not complete, we just tested. Our objective is to delete Tina Ali. Okay, so we run, we say delete a member, Ali, we select Tina Ali, oh sorry, select Tina Ali. Do you want to remove Tina Ali? Yes. Right, so now 5, oh, we still have Tina Ali inside of there. Tina Ali should not be there. All right, so that did not work. Why didn't that work? Excuse me. Sorry about that. All right, right. So if list at position x dot valid is equal to true, they did not mark Tina Ali as being having to delete. All right, if confirm is equal to yes. All right, Tina Ali. All right, to change the write file flag to F so that, okay. So why didn't it delete Tina Ali from here? Let's see if list X not valid. All right. What I would do here is I'll just go and I will print just for debugging information. I will print F %sign S, %sign S, and %sign C. Okay, and I'm going to print out the first name and the last name. The first name and the last name, and the list at position X dot valid information. Okay, so list at position X dot valid information. And we are going to run this, delete a member, enter first name, Ali, select one, Tina Ali, sorry. All right, yes. And maybe I should put a picture so that we could pause the output after it comes out, right? Oh, I had a %sign S here, where I should have had a %sign C. That may have affected my what I was putting in. So let's see, delete a member for Ali. All right, so maybe in that case, did we get something working there? Let's see, SBA members. Okay, Tina Ali is gone now. Let's try it again with Tina G. All right, for delete, enter first name James. We have Tina James, so 1. Are you sure you want to remove Tina James? Yes. All right, so look at this. Tina James had an F. Grace Simmons had a T. Jamie Martinez had a T. Tina Thomas had a T. Hannah Mendoza had a T. Everybody else had a T except for Tina James. Right. So when we check back our file here, Tina James is gone because I could not write Tina James because she had a T. Now let's try and delete Alicia as the last one and see if our backslash see if our inside of our write file, how that is going to affect when we have the last person being written to the file. What happens when we delete them, right? I'll put a backslash n here to make this a little more readable. So we want to delete and we want to take out Wilson. All right, so we're taking out Alicia Wilson 1. Sorry, 1. Are you sure? Yes, I'm sure. Okay, Alicia Wilson had the F. So, right, let's take a look at what happened here. You see this little hanging space here? That's going to cause us problems in the future because we tangled with that already. Okay, but functionally, our delete is working. Right? It's just that we have to to figure out under what circumstances do we not put back this what you call it, where our cursor to hang down. All right, and so what will happen is when I press show members of the club, right, sometimes, yes, with that extra space there, our program starts to behave a little strangely. Right, you see how now the program is crashing? It might be because of that extra little space there. Let's see if we fix that and see show members, it's showing. So that little extra space there that our right is causing in the event of a deleting the last person is causing some problems. So what can we do to adjust it so that when we delete the last person, we don't get that extra \n. Okay. Let's see what we can do. If we know the size of list underscore I, and we know that we don't want the last person being written. We wrote code for that. Every position in the structure array but the last position, we could actually do a little ratch before that says if not here, sorry. Let's say here what's the quickest way to do this? Let's go to our drawing board. All right. If we know that we don't want the last person to be written, sorry. Somebody help me through this now. What you all thinking about? All right. We know that the last person, we don't want it to be written. All right. Sorry. We know that list underscore I in this instance is going to be equal to 5 because that tells us how many people are in the array. Okay. And we also know that we also found out that the location of what we want, this from the delete function, the location here was equal to 4, right? That would have been inside of what would have been passed to us from the search function. Is there anything that we could do to make it so that when we call the right function, we could just delete, in the event of this being the last person being deleted, we could just simply write up to this point and follow the rules that we wrote previously. There's something that we could do from the delete function. All right. Before we write the right file, okay, we could say if LOC is equal to, right? So if the location to be deleted is hold on, now I just want to put this inside of here. All right. So if the location to be deleted is equal to list underscore I minus 1, what does that mean? Right? If the position to be deleted is the last position in the array, then what do? We could say list underscore I minus minus, right? So change the value or decrement the size of the valid list positions, so that by default, what will happen is that that last position is not going to be considered, and our code for here inside of write file should hold up, because we always say that the second to last position, you're writing \n up to the second to last position and not for the last position. So let's test it and see. So show all members of the club. Kalika is the last member, last position inside of here. right? So if we want to delete GRETT, we find Kalika, one, yes, right? Look at this. We removed Kalika from the potential list. And now if we press show all members of the club, Kalika has been removed. What we did is that we didn't mess around with write file to find the logic. We said, well, if it is that the last position, the last person has to be removed, and we confirm that the last person has to be removed, then we confirm that the last person has to be removed, then we will what you call this thing? We will reduce the size of the array by 1, which in reality, when we call write file, doesn't affect the code that we already had, because we had a rule that says after the second to last position, right? We made the last position we made the last position not possible to access, and we made the previous second to last the last position. So this code holds up against it. You all understand what I did here? So we could just clean up this piece of code. Good. So we could just clean up this piece of code and say if confirm is equal to yes, then change the right flag, do what we have to do if it's the last position, and I could put the right file inside of here, and then I could printf, right? Printf, member deleted successfully, right? And if it is that the person get cold feet and decide that no, they don't want to confirm, right? They don't want to confirm in terms of removing the person from the file, then we could just simply printf and say member was not deleted. Okay? And then we just put a get char after here. We put a get char after here. And that's it. So that we could now say, okay, if we want to delete somebody, let's say we want to delete, we say, okay, Tina Thomas. Are you sure you want to remove Tina? No. Member was not deleted. So if I go back and say show all members of the club, Tina Thomas is still there. Look at that. We have a working SBA program. Okay, we have a working SBA program. So at this point, we have all the functionality. We have the edit, we have the delete, we have the search, we have the add, right? And we can manipulate data inside of it. Everybody's good with this? All right, I'm gonna give myself a little applause because no, you always seem to Ezekiel. I saw yours, but I think that this is what is required, right? And look at that. It's only see it. We didn't even write 300 lines of code. It come up to 267. I guess if you add a little more validation and stuff like that inside of here, it might hit 300 lines of code. Okay. Anybody have any questions? Right? Yeah, approximately 300 might be where you would find your SBA. Well, yeah.
So I have a question on the problem definition though.
All right, I'm gonna stop recording from now, right?